So, hello, welcome to another episode of Beam There, Done That. Again, I'm joined with my co host, Francesco Cesarini.
Hi there, I'm Francesco, also co-host, and today we've got a very special guest, Sam Aaron. So he was originally a postdoc at Cambridge University, and when he was there, he ended up building a tool which is becoming a global phenomenon in both schools and nightclubs, which is, yeah, is making it really, really cool. Sam, why don't you introduce yourself?
Hi, I'm Sam Aaron. I'm a programmer and a musician, and I've been working for many years now on working on ways to make programming languages like musical instruments, figuring out how that might change what a programming language is, and also how you might interact with music as well. And I've been working on a piece of software called Sonic Pi, which is a tool not just to explore this, but also a tool to teach computer science in schools to children.
We're going to talk about the Sonic Pi, but I've actually heard that you're moving from the Pi, to the Tau. Can you give us a bit of background,
Yes.
for about that? How did you pick, Sonic Tau, and what is it, and how does it, how is it different from the Sonic Pi?
Sure. I mean, I'll try and summarize it quickly because I could spend a lot of time talking about this because it's what I've been thinking about for many years now. But fundamentally, Sonic Pi has sort of reached its sort of end of life in terms of rapid development and exploration, and it's really nice and seasoned, and it does its job really well. And it's got a lot of fundamental problems in its architecture that were baked into its initial design that I would really like to experiment in changing. Particularly, it doesn't run in a web browser, so schools really want web browsers now as their main sort of interface for programs. Secondly, it's not super secure because it's using a traditional programming language, so it'd be much nicer if that was sandboxed. And then third, there's no real collaboration. You can synchronize clocks and some cool techniques for doing that, but I want it to be much easier for people to get together and jam together. And so, in order to pursue all those three things, I've been really deeply thinking about how I might reimagine the architecture, the language choices, in order to actually meet those needs in new and special ways. And so, Sonic Tau is my attempt at the moment to explore and experiment in that direction. And I've got way further than I imagined I would do, and it's really quite exciting. And it's required a complete fundamental re-architecture of the system whilst also keeping it extremely familiar. And there's actually tracks from Sonic Pi now that work perfectly the same in Sonic Tower. Sorry, I'm getting confused myself. Regardless of the fact that there's concurrency and there's randomization.
So you basically, went from a tool which would work on a Raspberry Pi or on your local machine to something which would work in the browser. Is that correct?
Precisely, yes,
If we
and
were to
also on your local
simplify what
machine
you're
as
saying,
well.
yeah. And also on your local
Yeah,
machine, yeah. And
yeah. So I mean,
what, yeah,
you just need a web server, right? And then you host the app, the JavaScript, the WASM, the HTML, the CSS, all the assets. Um, but you can obviously run that web server on your local machine. And so I've developed it's like an Electron-like thing that uses the Beam as the sort of the web server and is able to serve those assets and then uh, wraps that around in a web browser using Chromium and Qt. But there's also this Towery, which looks pretty cool in Rust, which I'm exploring as well.
back in my uni days, so we're talking, mid 90s, early to mid 90s, it took us about 30 seconds for an airline node in Sweden to ping a node in Australia and receive a response back. With Tau,
Wow.
you're using Phoenix and the Beam's networking capability. So I assume, I'm taking for granted you're not using distributed Erlang, but you're still using, the Beam and its networking capabilities, to allow people to jam together across the world. How do you handle the latency of two people, coding, the same baseline, but in different continents?
Yeah, I mean, so this is still very much in development. I have experimental prototypes of various parts of this, which I've put into action. So I gave a TEDx talk in Manchester a few weeks ago, and there I put a QR code on the screen, and everyone in their audience to put their phones and went to the website, and that was obviously a Phoenix-backed website that was serving the assets, and those assets included my synthesizer, which then loaded onto their phones. Then I was then able to modify the code on my laptop, send it to the Beam running on the server, and then obviously it's using PubSub to then forward and synchronize those messages to each of the clients, the audience members, and they were able to play the sounds in time with each other back to me. So yeah, so that's using the Erlang as, or the Beam, as the communication infrastructure.
I'm sharing your TEDx talk, in Manchester right now. That was super,
Well,
super
that's an
cool to
much
see.
older one, so that's not the one I did this in,
Oh,
but
that's an
yes.
older one. Oh, okay.
Yeah. Yeah.
You've had
I'm
multiple
talking
ones.
about
Cool.
technology I've developed in the last sort of 6 months. Yeah, that's like 8 years ago, 12 years ago.
Uh, Oh, okay. Oh, yeah, you do look. No, you've not. You don't look younger on the video at all.
Thank you very much.
Is your is your latest one available?
I'm not sure if it's going to be available because there was a bunch of technical issues. So although I did get them to
Okay.
make the sound, then my Wi-Fi connection disappeared. So I lost a connection to the server, which is super frustrating. And then they didn't record my screen, so or at a good enough quality. So I didn't actually, don't think it made it to the video. But this is a demo I'm going to be doing at the conferences going forward. It's really quite fun to do. So I'm sure you'll see it pop up at some
Okay.
point soon.
Well, we'll make sure to capture it at CodeBeam Europe in November. Great, and make sure we don't mess up the recording. Nice.
Yeah, and give me Wi-Fi that works. That was the weirdest thing. I spent so much effort trying to optimize the bandwidth and the packet sizes so I could get it to everyone's phones really smoothly using CDNs, etc. And actually, the main issue was the fact that my Wi-Fi didn't reach to the stage. It worked backstage, but not on the main stage. So, so yeah, maybe a cable would be useful.
Nice. Back, yeah. Back to the mid 2000s here. Don't tempt the
No,
demagogues.
I still only trust cables. The Wi-Fi is not a reliable infrastructure. It's useful, but not reliable.
Yeah, I'm hooked in over here with my Ethernet cables. I ran a couple. It's just too reliable. Yeah, but actually now
Yeah,
suddenly
exactly.
my router just shuts down randomly sometimes. I don't know what's going on. You know.
Just cross at you.
But coming back to what you're working on, you swapped out the familiar kind of Ruby DSL for something more like with a Lua Earl. What was it like working with Robert Verding to get that
Yeah, so
running as
like
a first class
actually
citizen?
in between
Yeah.
Sonic Pi and Sonic Tau, I spent a bunch of time working with a really nice guy called Guy Brown at the University of Sheffield, and we developed a piece of software called Bleep, which was using the Lua as the runtime language for the synthesis engine. And that was a lot of fun. And so it was really nice to be at the bleeding edge with Robert. He's always like whipping ahead super fast, seeing what he's doing. And he's just it was just a great chap to work with in general. Deeply knowledgeable and really helpful. And he was really keen and interested to make sure that any bugs and issues were fixed quickly and promptly. He really obviously cared about what he was doing.
He was on the show with us a few weeks ago, and so the episode with him is out. And actually, we're recording another episode very soon, which will come out right after yours. Again, where they used LueURL as well for test scripts. So
Yeah.
it's out there.
So Lua was like a great choice because it provided the sandboxing and then also a really easy way of interlocking into the Beam in general. So calling Erlang or calling Elixir was really, really nice. And then that gave you this very malleable, flexible language, but in a really clear sandbox, which was actually really an interesting proposition. The only issue for me with it was that once I'd spent time developing I actually spent a whole bunch of time converting the synthesis engine called SuperCollider, which is a C++ low-level synthesis engine, into something which works inside the web browser using web audio worklets. And once I'd figured out how those work and the architecture's there, it just seemed really appealing for me to put my programming language in the constraints of an audio driver, because you get this amazing quality of really good timing. So despite the LueURL being a really good choice for that malleability and flexibility and sandboxing, actually the lure of working inside the really high quality timing context of an audio worklet or a high quality, high priority audio thread, in the same way your DAWs, digital audio workstations, and your fancy pro audio software works, was just too appealing for me to not experiment with. And the results I got are really quite extraordinary. I'm more excited about them than I've been for something for a very long time.
Yeah, I'm kind of curious about why you went with Luro, because I know with like Elixir especially, you can make some pretty interesting DSLs, using macros and so forth. So what was the
Yeah,
kind of the decision
specifically,
process?
yeah, the issue really is I want to put something that anybody can play with, but you don't necessarily trust them. And so if they write nefarious code, they can't really damage the system too much. So the idea of Luel is it's completely sandboxed. It doesn't call out to the system, doesn't do any network access or any disk access or calling to your databases. And I even spent extra effort into reducing the amount of memory that Luel processor was able to get, and also to restrict the number of instructions. So by counting the operations. And so that way you're really trying to restrict essentially the attack vectors, which are either from nefarious people or just children messing about. And so you want to have that protection. And so the problem with a traditional language like Ruby, which I was using before, or even Elixir or Python, is they're program languages which essentially make it easy to call out to all the system operations. And so that's something I wanted to avoid.
When we launched Try Erlang, it was a race to let the virtual machine, which was running it, crash. One person was successful. We actually, I think they won actually a signed copy of my book or something like that, but only
Nice.
one. So, and there was a lot of things that had to go in and block. So, and for those of you who don't know, Try Erlang was allowed you, this was, before containers, before WebSockets, allowed you to go online and just type in Erlang commands in the browser and then execute them in the backend. So yeah. So
Yeah, super cool.
Sam, yeah, it was back in the days, yeah. And now it's really easy to do. That wasn't the case back then. But so Sam, most developers have a minor heart attack when they see a supervisor restarting a process in production. You, on the other hand, have turned process crashes into a rhythmic choice. What's the
Yeah,
most
sure.
musical? What's the most musical bug you've ever encountered on the Beam? So be it Lua, Elixir, or Erlang.
Most musical bug. I mean, that I think that I remember listening back to a podcast a long time ago where they were discussing how in the really olden days when computers were big machines in rooms, you could hear the actual execution of them and you could hear the patterns when they went wrong. Um, and that was always a curious thing for me. Obviously, we can't do that now. We can use like super microscopes to and slow time down potentially. But the idea of being able to rhythmically hear sort of a malformed operation of the system was really interesting. And actually, that's turned out to be exactly the best form of testing I've got with Sonic Pi and now with Sonic Tau because I'm developing it to be the same operations as Sonic Pi, so it should sound exactly the same. Is knowing exactly what the semantics should sound like and then being able to hear any sort of deviations from that. And the human ear is really good at being able to perceive that. And so, yeah, so being able to rhythmically hear bugs has been probably the most musically useful operation. Of course, they don't always sound great, and sometimes it's just subtle differences, so it's not necessarily musical, but the rhythmical no, the fact that we can hear patterns through time allows me to listen to the sounds and to observe or not whether there's an actual issue with the system, and then figure out what I need to do to fix it.
You're one of the few people who can say that their IDE is also their musical instrument. Are you still an Emacs person, or or have you moved on? What what
That's a
what
very good
editor are you
question.
using at the moment? Yeah.
I mean, so that's yeah. So I've evolved quite a bit. So I definitely have an Emacs mentality, just as much as I have a Lisp mentality in my mind in terms of programming languages. But there was a point where, I mean, I did develop my own Emacs config, which actually got used a whole bunch, which was really weird because I developed it for my performances, and it was actually used by large organizations for a while to do closure development, and it was primarily targeted towards closure manipulation because that was my old system was called Overtone. I was working with Jeff Rose, which is the first major live coding system I worked on. Um,
I remember that.
and
I
but
think that I think that's when we first met.
probably
When
you're
you
showing
were
that off, yeah.
when you were doing Overture and you're actually playing.
Through Emacs. Yeah, I
I
mean,
think
the
it
problem with
was yeah,
Emacs is it was
you were
just a
playing for
nightmare.
Emacs at CodeMesh. Yeah, at CodeMesh. It was a long,
Yeah.
long time ago. That was an amazing conference. Yeah.
So yeah, but yeah, the problem with the Emacs it was just a bit complicated to perform with. It was too many things to go wrong. Sonic Pi really showed the way in terms of having a much simpler experience, even though you couldn't do as many things. The things you could do were much more easy and accessible. But the Sonic Pi editor, uh, only till like so for 12 years or so, had only Emacs shortcuts. So I was definitely pushing the Emacs hard down people unnecessarily. Now you can actually change to a more like Windows friendly shortcuts or whatever. There's still no Vim, but
It,
I have a lot of respect for
uh,
Vim. I still pop into things and edit in Vim for fun.
it, it does remind me of when I moved over to Emacs. I did it in VI mode, so all of my
There
VI,
you go.
and that was even before Vim. All my VI key accelerators would work. So yeah,
But
great.
yeah, the
Now,
idea of a flexible programming interface is a really from the Emacs days is definitely there as a philosophical construct. And with the Sonic Tau now, I'm much more capable of doing even more interesting, deep connections between the live interface of what you're editing and what you're observing, and the runtime memory execution of what the system's actually doing. And in live coding, that's always been a main issue is trying to connect those better, because once you run some code and it's running, you can edit the code, and now they're no longer in synchronization with each other. So finding ways to deepen that synchronization feels very Emacsy to me, and it's something I'm working actively on with Sonic Tau.
when you're up on stage at an Algorave or playing the Royal Albert Hall, you feel more like a lead guitarist or a system administrator, trying to keep the legacy server, from melting down. And
Both, probably. Alluding to, I guess. I mean, it depends on what I'm doing and where, really, and the level of improvisation or who I'm collaborating with, and the level of synchronization I need to do. So it really depends. And sometimes systems are going completely out of control and you're stressed and you're trying to debug things live in the moment. That can be stressful. But you try to limit those and you try to make the system robust against that. And you try to be able to know when the kinds of errors that are actually normal, like you can break a string on a guitar, or you can miss a string, or there are standard obvious errors you could make as a musician, and being able to have the system be tolerant of that and to know how to recover. So, like being able to mistype something and have a runtime error, and have the thread be able to detect that, and to be able to then have ways to recreate the thread. So it's not just in terms of like a process tree being able to detect that the worker's not doing something and kill it and restart it, but to be able to provide ways to insert replacements in a way that's in time, that's not just concurrent, but it's actually in time with all the executing things. So it's like meshed in temporally. Building all that kind of infrastructure, which is part of Sonic Pi, helps with both of those. So you reduce that stress of I have to do this on time, or I can't make a mistake, and then you increase that sort of the rock star nature, because you feel like much more confident about the tool you're working with, and know that you can fix the bugs that happen. And actually, often when you make a mistake, the crowd really likes that. They think you've done something, you've brought the music down to something simple. You sort of take that as an opportunity rather than see it as a mistake.
so basically, you also never deploy right before the show.
all the time, yes. I mean, the show is live deployment. I mean, it is modifying the code live, changing it live. So when I'm performing, I am creating and killing whole trees of threads concurrently as part of the process. I mean, that's underneath the hood. That's how it's working. Even in the new Sonic Tower, I have a virtual deterministic tree of threads which are all doing a computation simultaneously, and I'm modifying and changing that tree structure, which is then affecting and controlling the sounds that are being produced in the composition. So yeah, it's definitely live concurrent modification. Super fun.
Are you using the live upgrade capabilities of the Beam, the live coding upgrades?
No, no. So the live coding parts are done with the Beam. So in Sonic Pi, I mean, to try and connect where all the Beam bits connects, because it connects in lots of different ways to lots of different parts of my work. So with the Overtone, that was purely Clojure and the JVM, and a system called Super Collider. That's the single piece of thread which runs through all of my work. So that's Super Collider is this amazing synthesis engine that you send it messages and it makes cool sounds. And then in Sonic Pi, instead of using Clojure, I used Ruby to describe the language, and that sends messages to the SuperCollider synthesis engine the same. But then we wanted to do I/O, so we wanted to be able to have like MIDI input and to implement a scheduler to send messages out, well timed on MIDI. Similarly for network messages, And so that was when I met with Joe Armstrong and explained these ideas. He was super interested, and he implemented the first scheduler for Sonic Pi, which does the I/O part. So it deals with messages in and out of the system and making sure they're on time. And then with the Bleep system I developed at Sheffield, that's when I was working with the Beam as for everything pretty much, except for the sound generation. And that was using web audio, not SuperCollider, using synthesizers that a guy developed, which sounded really cool. But we were using the Beam for serving through Phoenix, serving all of the assets, doing all the web, using it for all the coordination, using the PubSub stuff, and using Luerl running on the server, running the user's code in a sandboxed environment, and then sending time-stamped messages back to the clients to trigger the sounds. And then with the Sonic Tau stuff I'm working on, the Beam is no longer part of the language process because I've got this clockwork language which runs inside the audio driver thread, which is super exciting. But I am using the Beam for all the connecting the different Sonic Taus together to do that jamming stuff we were talking about earlier, to allow people to jam together across the world. So it's more into a sort of a mesh, networking mesh of nodes, and also the ability to run a native app where you have the web server running locally on your local machine. You can do it in a bunker in sort of underground Finland, which is like where you have no internet connection. You want to be able to do that and to rely on that without having to open Safari or whatever. Yeah, so Beam's touched where I've worked on in various places over the years.
Joe Armstrong was a huge fan of Sonic Pi. Can you tell us more about how you first met him and about when you guys started working together on Sonic Pi?
Yeah, I mean, it was exactly when I was thinking about doing some kind of I/O, and I wanted to build a scheduler. And SuperCollider has this amazing scheduler built in, so you can send it a message with a high resolution timestamp, and it will park that message until that time, and then it will then execute that message on time. Now, I thought that was just because it had really good C++ timers and high resolution timers and all that kind of stuff, but actually it turns out it's because it's driven by the audio clock, and the audio clock sends these ticks, fine resolution ticks, and then on each tick you can look at the clock stamp and you can say, is it time for this message to be sent on or not? But at that time I didn't realize this. I thought it was all sort of just good simple C++, and maybe I could build something like this, but I didn't have the skills. And I imagined a system where you would just essentially create a thread per thing you're waiting for, and it would just sleep for that amount of time and then wake up and send the message on. And obviously it turns out that that's exactly the kind of thing that Erlang's really good at within the threshold of traditional computing timing guarantees. So within sort of 10, 20 milliseconds, then it's actually really good at that. Although it wasn't the best on Windows. So I had to spend a lot of time to pester everybody implementing the Beam on Windows to get the timer resolution more accurate to allow this, because it just sounded more off on Windows than it did on Mac, and that was because they were using coarser grained timing routines, and so everything was just not much more loose. But yeah, so Joe wrote the first scheduler to do that I/O timing stuff in Erlang, because when I explained to him that architecture, it'd be really nice to be able to have a bunch of events, throw up some sort of process thread perfect. This is just how I was explaining it in my mind. This is like how I could semantically describe what I wanted. But it happened obviously to one-for-one match what Erlang would enable really, really easily. And Joe his eyes just lit up and went, "Oh, I can build that." And then like a day later, he just sent me the code. So it was really nice to start collaborating with him quickly on that. And he was like a mind beyond minds. It was just so much velocity. I struggled to keep up with the amount of information he was throwing at me.
Do you know what actually inspired Joe to work with you on this? What was the thing that really got him going about it?
Yeah, so Joe was actually, I think just Joe was generally interested in music. He played the piano beautifully. He had like weird synthesizers. He was showing me, look, I bought this cool synthesizer and lots of cool buttons and knobs and dials and whizzers and things. So I think he was just generally curious about music. But I think he saw we had a connection on how music could be modeled in terms of events. So he always loved to talk about the idea of having a composition which was a concurrent set of events just thrown out at the scheduler, which would then, through time, spread them out correctly and render them as the actual composition. So yeah, so this idea of notation of programming languages as a form of notation for music was something he just connected with immediately. And I think what was also quite nice is we had a lot of interesting conversations about the problems of working with multiple trees of threads. Because it turns out that in order to develop Sonic Pi in a way that worked reliably, I ended up having to write my own sort of threading system in Ruby, and then the threading system had sort of hierarchy, so you could control and kill and watch multiple threads in groups. And this all sounds like OTP, and essentially I had written like a half-assed implementation of a crappy version of OTP. But that provided a ton of rich conversation material between me and Joe that where we were able to connect, I think, quite strongly. And so, yeah, so I think it's just the basis of the fact that programming languages really can be musical, and Joe saw that the systems that he'd been developing really correlate to systems of music, and there's no hiding the fact that I've been working around and connected to the Beam for so long, because the ideas in the Beam are very similar to the ideas that I see as a really key part of making really powerful, expressive, well-timed musical systems. And even in the Sonic Town working on, which I'm really sad I can't talk to Joe about really, it does embody a lot of the ideas of the Beam itself. I mean, I have a little VM running bytecode that are deterministically scheduled. So and they also are they all isolated, and they can send messages to each other through. I mean, I have a global bus, but it's still a deterministic, well-ordered sort of like thread-safe tuple space. So yeah, so there's a lot of correlation between all these things that really I think Joe saw and he embodied and just fueled so many of our really exciting conversations.
Now I'm kind of curious. Working a lot with Joe, did that bring any kind of influence to you and made you kind of change differently, like with how you work or how you kind of going to architect everything within Sonic Pi?
That's a good question. I'm not entirely sure it did. I think that we were quite similar in the way you thought about problems. And so there was more resonance than, that's a critically different way I would approach that. I'm going to change how I'm doing this. It was much more, we just kept nodding in agreement. So, I mean, I guess there was encouragement for sure, and certainly helped. Like Joe's work was really instrumental to enabling me to get to the next stage of what I was doing. So he provided really critical building blocks for that. But it was more, I think, much more just general excitement, encouragement, and just being able to share and talk at like a million miles an hour with somebody about your sort of deep interest and have it resonate with them, and then they share ideas back. I think that was the magic of that relationship.
Was the move to the Beam so beyond the networking elements you discussed because of the need for soft real-time guarantees? Or were there any limitations in the Ruby architecture, which you felt only Erlang could solve?
Well, so I mean that's a very marketing question there, but to be perfectly honest, the reason why I've kept with the Beam as a key cornerstone is because it's just amazing technology, and I can rely on it. And in terms of Sonic Pi to Bleep, that movement was clear because the Beam offered a much more well-engineered, stable, production-ready version of the kinds of semantics I had haphazardly implemented myself. And so it just made complete sense to not use Ruby, but to use Erlang or Elixir or a language that ran on the Beam for a programming language which was highly concurrent, that wasn't allowed to stop and pause, so GCs were not a good idea. That also managed trees of hierarchies of threads, so an OTP-like library that isn't just thought about and implemented, but had been engineered for many, many, many years. And this is like a really, really one of the most important parts of, I think, of the whole Beam ecosystem. Isn't that it's like necessarily a beautiful mathematical perfection of a truth or a proof. It's something that's actually clearly been engineered and battered down and tightened and tightened and tightened over the years, and that really shows. So it's really just the high quality engineering and the fact it's a highly concurrent environment, and the semantics match what I want. The only thing that's stopping me using it now is because I've discovered that I can actually get better timing by not running as a regular programming language, but running as a callback mechanism. So my new programming language it doesn't have a starting point and an end point. It's literally just a series of callbacks which kind of shift the state one tick at a time. So it is like clockwork, and that gives me this new quality of timing, and lack of jitter. Essentially, that's what I'm trying to remove. And this is one of the biggest problems with music in general, is we can handle latency okay, because I mean that's what a church organ is. It's quite a considerable latency, and you can still learn to play a church organ. But it's the jitter, it's the random variance between when I want something to happen and when it does happen, that you can't control so easily when you're working with a computer that's doing a bunch of other stuff at the same time. This is where you want to try and reduce that as much as possible. And this is a critical thing for high quality audio feeds. If you're just listening to music, you need to make sure those numbers, which represent the sound waves, are sent to your headphones in exactly the right order at the right time. And so this is what the audio clock is very good at. So if we can fit our language into exactly the same constraints, then we get this amazing quality of no jitter, high quality timing. So that's the only reason why I've moved away from the Beamers. I've got these very niche requirements, and I've found a way of actually achieving them in a quite novel and exciting way.
I mean, it's very much about using the right tool for the job rather than the tool at hand. This is something I've said many, many times here. And
Totally.
yeah, and if you're dealing with soft real time, what you're doing is, getting to the border of hard real time, because it's not easy to deal with garbage collections
Nope.
and ensuring
So
that
I allocate
the
all the
stream
memory ahead
stays.
of time. I use a big
it,
arena to actually
exactly,
put all the data structures
exactly.
in. Yeah.
Exactly. But before, when you were talking about C++ and picking the right tool for the job, a quote from Robert Verding came to mind. If you try to re-implement Erlang's concurrency model, and many have tried to do that in C or C++, you'll end up with a slow, bug-ridden implementation of the beam. Going back to what you were saying earlier, though, what you were just saying now about removing the jitter. In music, things happen simultaneously. And where do you draw the boundary between beam processes mapping to musical voices, loops, and effects? So where do you use processes? Where do you use Erlang? Where do you use Rust? Where do you tap into
Yeah.
these existing APIs? What is the exact boundary there?
Yeah, I mean, it depends on how you want to care about the operational semantics of your system. So how you can use the slowest, crappiest language with the most amount of jitter and weird GC pauses that pause the system for an hour. If all you're doing is rendering a sequence of notes and times, like Joe imagined, and that you would then just fire off at a scheduler. So if all you're doing is rendering the events through time of what that composition is, how that's rendered, whether it's smooth or slow and chunky in the way that the execution happens, it doesn't really matter. It's only when you want to care about latency, of when you want to interact as a human with the running system. If you want to reduce that time down, then this starts to really matter. So if you want to be able to press a button and that button to run some code, then you start to care about how quickly can I reliably get my message to the system in a way that interacts with the timing of it well. So what you tend to do is to get better timing, you usually schedule things more in advance. And in Sonic Pi, we schedule everything half a second in advance. And that's what we needed on the original Raspberry Pi, because it was so swishy-washy as a system, that you needed to schedule everything sufficiently ahead of time so that the scheduler was able to do it on time. And so if you're caring about 10, 20 milliseconds, and that's good for you, which for most things that's fine, then the Beam is going to be totally a great system to work with. But if you care about getting that lower, and certainly reliably lower, so on a traditional sort of audio chip clock, they're running at 48K. Maybe in the web you've got 128 bits in samples, in your buffer. So you're working at about just under 3 milliseconds per clock tick, and they're actually super accurate. So if 3 milliseconds is your goal, or 2.67, whatever it is, then then you need to use a different system again. So that's where I would move into the Rust thing. And actually, I figured out I can put most of my stuff, including the whole concurrent VMs, the whole data structures, the whole programming language, all inside this little audio thread. And so I'm now really using the Beam for the networking communication. So I want to send my code, VM bytecode packet to my listeners, for example. And so it's just really, I'm not doing the very immediate execution on the Beam. I'm doing all that in my weird new clockwork-like VM system.
So I think that we can start to wrap up and look at the impact that Sonic Pi has had on both the industry of kind of music production and also education itself. For the algorave kind of scene, how has the Beam enabled a new kind of like performance culture where you can create all the music using Sonic Pi?
That's a good question. I mean, I'm not entirely sure that people who live code in general are deeply technically aware of the internal design systems used. So I don't think that a lot of live coders are aware that the Beam is necessarily part of Sonic Pi. And it's the only live coding system other than this Bleep thing, which I developed at Sheffield, which was used by a really cool band called the Black Dog, and they did make an EP with it, but it's not been used by anybody else for any other reason. So I'm not aware that there's like a direct correlation between the Beam itself and live coding culture. But certainly the technical affordances that the Beams enable Sonic Pi have affected people. And so the ability to work with MIDI, the ability to send network messages between Sonic Pi instances has connected people in ways that wouldn't have happened if Joe hadn't been part of the project. But yeah, I don't think there's a direct correlation between any single technology. I guess the closest one is this SuperCollider synthesis engine. That's really a lot of live coding systems use this. I'm excited to work with it in the web now. I've ported it across. That is one common thing. So that kind of like the SuperCollider is kind of like the Beam for live coding people.
When it comes to the education scene, when Sonic Tower, right, when it's used for teaching kids coding through sound, does the Beam environment provide a more like indestructible environment for kids to learn, so that way they can kind of experiment and not worry about breaking something?
So currently in Sonic Tower, no, the Beam isn't part of it at all. It's just served as HTML, JavaScript assets. The Beam is the point of the Beam for Sonic Tower and its related technology is to provide that ability to jam together. And this is something I'm very careful about implementing, because I know that it's something that, although it's a nice idea, it's something that could easily be misused and mistreated. So if anyone out there is interested in helping me, especially with the legal elements of this, how we might create a collaborative environment, like technically aside, just sort of politically and socially and legally, I think there's a lot of issues there. But that Sonic Tower I've basically abstracted from the Beam into this audio workload context where I have this amazing timing and I don't have any memory allocation, so I'm operating at a sort of a lightning speed, which is lovely.
What features are coming next? What are you working on right now?
So I'm working. I've been working on this thing called Tau 5, which was Sonic Pi version 5, and switching across for quite a while now as a sort of fuzzy sort of keyword for the set of prototypes I've been working on. And the only really tangible thing that's come out of a lot of wacky development ideas and experiments and thoughts. And I mean, this is research. It's sort of a messy process that you don't really know how it's going to turn out. But one of the things that's turned out really well is this idea of building a clone of Sonic Pi. It seemed like a nice idea at the time. In the same way, if you hear of JavaScript developers, they've learned of a new JavaScript framework. So they go away and they build a to-do app, the same to-do app they built in all the other JavaScript frameworks, and that's because they know the to-do app, and that's not the new novelty. They're learning the new framework using something they understand as sort of guide rails. And so with my new system and the ideas I've got, just to see if it would fly, it's like, well, could I build a Sonic Pi clone? And so that's what I've been doing, and that's really seems to have taken off in terms of certainly my interest and my ability to get it a long distance really quite quickly. And a lot of that is because I've spent the last sort of 10 years designing this in my head, imagining what it would look like. And now I've found a way to actually implement it in a really clear way. I've been able to really sort of click all the pieces together. So what I've been able to do, I mean, even just today, I managed to solve implement something that I've been wanting for many years in Sonic Pi that I just couldn't implement because the implementation of Sonic Pi grew so much technical debt that although it worked reliably, it wasn't correct. So it wouldn't pass the maths tests, but it does pass the engineering tests, which is fine until you want to then modify it in a way that breaks the engineering choices. And suddenly now it's sort of leaking and falling apart. And so I haven't been able to build a couple of features that I really wanted for many years, and they are now in Sonic Town. These are to do with live hot swapping threads across effects context. So you might have a thread which is running your kick drum and another thread that's running the bass, and you might want to swap them in and out of, maybe add some more reverb to the kick drum or add some distortion to the bass. And so you might want to wrap that bass thread with a sort of distortion context. And you could do that with Sonic Pi, but you couldn't swap that context out. It was sort of hard baked into that thread at birth, and you couldn't unwrap it and move it on. And now I can do that, which is actually musically is giving me great new affordances. And then also I've been able to do a lot of really exciting work figuring out how to visualize a running execution of the program. So the language now starts to flash when the words are executed in time with the music. You can see an event stream for each thread as it's generating events, and see how those correlate your expectations. Each of the threads also is correlated to an effects mixer, so you can see a live audio waveform of exactly the sound just that thread was making. And so these are all great tools for performance and for visualization, but they're also really great tools for education, because so many times you don't know why something's happening, and you've got like a tree of threads which has just spawned a million threads, but unless you've got a good, I mean, this is what the Beam started to add from an early age, was amazing telemetry tools and amazing observation tools, so you can just literally watch what the Beam's doing. And so I'm essentially adding those kinds of tools into the live coding system so that it makes it easier for me to see what's going on, easy for people to teach people so they can explain why things are happening, and just looks really cool in terms of a visual when you're doing a performance in a nightclub.
It almost sounds like you've taken, I think, a lot of the features we have in the Beam and originally in Erlang, and started applying them to other programming languages.
It's exactly it. It's exactly it. So I have my own deterministic tree of threads,
Mm.
which are all little VMs,
Yeah,
which run their
yeah,
own bytecode,
yeah.
which is all specific to the Sonic Pi context.
Are there plans, to leverage more of these features in what you're doing?
In what way? Sorry. I mean, I think that,
Um,
I still feel like I'm building a prototype system that I have a high chance of
well,
throwing away and starting again.
I,
I'm learning a lot. But I do feel like the system is like really good for well-timed events, and that could be of any kind. It doesn't have to be musical events. But when you're dealing with something where you really care about the latency and the jitter, and you're running on not weird hardware, but you're running on a normal computer, then this system is going to be really good at being able to generate and manipulate and work with those events. So be able to receive events and be able to, within 3 milliseconds, react to those events.
I laugh when you're calling it a prototype. An engineer doesn't understand the problem they're solving until they've actually solved it. And from
That's
what we're
exactly
seeing,
it. Yes.
once you've solved it, and it works, you'll think up of a million better ways to go in and do it. So I mean, first make it work, then make it beautiful. And once you're making it beautiful, you often go in and refactor everything
Yeah.
completely.
And
Yeah.
but actually, I've got a step before that, which is first see if it works, then make it work, and then make it beautiful. And I've been very much in that first phase of, is this actually going to work? Is it a good idea? I've got absolutely no idea, and it's turning out to be much better than I imagined.
I have a kind of a question for you about, since you've been working on this for a while, is there something that developers can learn from, the whole creative coding kind of experience if we started kind of working with this? Will it start to affect us in such a positive way for our own development?
100%, yes. And a lot of that will be to do with a different sort of stance or philosophical approach to what you're doing. I think that just the idea of play and development through experimentation and not knowing exactly what it is you're building, and not having that be a big problem. because we don't really. And it's all a big charade and pretense that we know exactly what it is we're building. And it's only when it starts to stick to the surface in ways we didn't expect that we go, oh, that's interesting. And let's explore that further. So the ability to see development as sort of a playful, creative, fun activity, I think, is that attitude. It's not always applicable, but I think it actually has great value when used carefully and appropriately. It's also to recognize that code is not just a tool for business, but code is a tool for human expression, and to value that, to understand that actually the biggest impact we're going to have with code isn't building the next database, it's building something that actually everyone plays with and interacts with and communicates to each other with and through. And so I think that's more attractive and interesting. And that's not necessarily something that's got a direct commercial value. And I think Creative Code, in its essence, sort of challenges that. And certainly there's a lot of sort of anti-corporate attitudes I don't necessarily associate with all of that. I think it's good to have a range of different attitudes. But just ability to say that software doesn't have to be, by its essence, a commercial thing is actually really, really important thrust, I think, from the creative coding movement in general. Seeing concurrency as exciting sort of material to work with, like Clay. I mean, we're starting to see programming languages in much more interesting ways, rather than just as tools to make more tools, but as a medium and a material themselves. And we sort of talk about maybe that we lose new programming languages due to AI being able to generate code really quickly and accurately, and this may or may not be the case, but still working with an interface as a human is a really important way of expressing yourself, whether that interface is poetry or dance or making swords, or coding. And I think that's never going to go away when humanity understands that code is actually just another material with which to express ourselves, and we can do that in really beautiful and human ways.
Where will we be seeing you play live next? I've heard rumors about you playing
Goatmire.
the Goatmire. Yeah.
Yeah,
What
I'm
about the
playing in.
Philharmonic?
I mean, I've got booked up so far. I've got a gig in Munich, gig in Portugal in next month, and then there's Goatmire coming up in Sweden, which is an amazing conference, the best ones I've ever been to in my life, and that was a really nice experience. And then are there some more Beam conferences we can talk about, Francesco?
We actually booked the Philharmonic Music Hall in Harlem for you. So, you'll
Amazing.
be playing that. You'll be playing that, hopefully. That's for Cobim Europe, October, 21st and 22nd. So yeah, really, really looking forward to that. But most important, where can we find the dates of where you'll be playing?
That's a good question. I
I-
mean,
Is there
usually
is there a
I'm
website online or?
yeah, so I haven't got any public gigs currently. So I've only got conferences and internal corporate events lined up. It's one of the strangest things. I have played music festivals at various points over the last sort of 20 years, but it's not been a common recurrence, and it's always been quite tricky to communicate with traditional music vendors and festivals about what actually live coding music is, and that it's got great value. And I think that's changing. I think in the last sort of couple of years, we've seen a real quite explosion of live coding artists, but it's still super niche and super hard to really open those doors because there's millions of artists all competing for the same slots. And so I've been really focused on doing the corporate events and the conferences, because it's really great to work and to talk to a technical audience. That's just a lovely thing in general. And of course, also it helps to fund the work because all my work is free. I give it away for free. So I don't have any corporate backing that's driving this. And so, yeah, those events are able to help maintain this development and keep it free for everybody.
You should reach out to WOMAD, the World of Music and Dance, and suggest you
Would
play a
love
gig
to.
there.
Yeah, I mean,
It's a great
now my new
music
system's
festival,
really
and
starting to come online. Yeah, I
they,
feel
they
like
even have a
I'm starting
science
to
tent.
open up new opportunities. Sorry?
They even have a science tent there on the campus. They've got their own,
Perfect.
planetarium. You could even give a talk and yeah, and a
Yeah, well,
gig. But you know, yeah,
that's a beautiful thing of what we do is as technologists, is we make these amazing systems, and if we can find ways to share those systems with others, to open up the box and let people see inside and play, then we're really able to share more of our work and communicate it with a wider audience. And so, yeah, having the best gigs I've ever done is where I've given a talk and communicated and shown people how it works and shown people the deep technical aspects, but also the deep musical sort of creative aspects. And then in the evening, done a performance at a party. That's where it's worked really well, because people don't just enjoy the music for its music sense, which is great on its own, but they have a much more deeper connection to how the music's being produced. And typically, if I can, I'll project the code behind me so people can read what I'm writing live and see what I'm typing. And if they've got any understanding of the system, they'll be able to anticipate what's happening next.
We've talked about conferences, we've talked about corporate gigs. How can our listeners support your work?
It's a very good question. So, I mean, I think in general, just the fact you're listening to here, hi, I'm Sam. It's great that you're here. Just go and talk to people about how code is creative. That would be the most powerful and useful thing. If music is interesting to you and others, then talk about live coding music. There's a whole bunch of really cool languages. The systems I've built and described, so Sonic Pi, Overtone, and Sonic Tau, are three of many systems. And just like in an orchestra, you could say, well, brass is not for me. I think I'm going to play violin. Same with like coding languages. There's many to play and work with. And if of those, then Sonic Pi and Sonic Tau are interesting to you. If you like the idea of building a programming language, which is not just a really powerful performance tool, but is also a tool for teaching and education, and trying to solve both problems at the same time and to reap the value of what you can achieve when you do that. Then yeah, talk about that, use it, play with it. They're both free, open source. Sonic Pi is an app you download that you can run on your Mac or on Windows. Sonic Tau is a website. You can just go to the URL, sonic-pi.net/tau, TAU, and play with it. And then if you still are interested and engaged, and so obviously now I've filtered away down to small people, then please do consider supporting me on Patreon or on GitHub sponsors or any means you can. Spread the word, share it with others, because with a lot of very small donations, I'm able then to hopefully have a sustainable sort of life going forwards, versus having one organization maybe that's backing me for a bit, but then can pull the funding without any warning. And that's a really sort of scary position to be in. And so it's, so just generally having fun with code, supporting the idea of creative code. If music's interesting, play with Sonic Pi. If that's interesting, or Sonic Tau is interesting, then support me on Patreon. That'd be amazing.
And yeah, you go in sonic-pi.net, and yeah, under
so you're looking at now.
You'll find the Patreon and the GitHub sponsors buttons. Yeah, so really encourage you to help Sam and help fund his work. It's for as little as a coffee a month.
Yeah, that's a great thing, and that's the cool. Is like you can support me for a couple of months and then drop out, and it's that churn is totally understandable and fine. And that's where it becomes sustainable, because you want to be able to support people popping in and popping out and supporting only when they can, or when they have a direct interest in what I'm doing. That might be only for a short period, and that's totally fine too.
Yeah, and there are also official courses.
I do believe in this model. I really feel that there's a lot of programmers out there that could build amazing things if we could find ways to sustainably fund them and not have that funding be directly correlated to some commercial outcomes. And to support play and experimentation and research where you just don't know if it's going to work. So like the make it good, make it better, or make it beautiful, see if it works phase. And so I think that's finding ways we can do this, I think, more globally is a really important conversation we ought to be having more frequently at conferences and venues, to find ways to support these people who are doing the great work they're doing already, but also to enable that next generation of people who could build that amazing expressive software that we can only dream about right now.
Thank you, Sam, for being on the show.
Thank you.
Just for the record, this episode was recorded on April 14th, 2026.